They told us space was silent, that beyond the hum of our machines and the crackle of cosmic dust, nothing was listening back. But then came the data, a heartbeat in the noise, a pattern no one could explain. It began on Mars, hidden in 43 minutes of missing telemetry, and ended with a reply from the edge of the solar system. What if the universe isn't empty? What if it's been speaking all along, waiting for us to finally hear it? Tonight we follow the signals, the silences, and the people who dared to ask the question every government was too afraid to answer. Because somewhere out there, 3i Atlas is still moving. And maybe, just maybe, it's not alone. In the autumn of 2025, Mars fell briefly silent. Telemetry streams that had run unbroken for years showed gaps, missing packets, shifted timestamps, unexplained noise at the edge of the spectrum. At first, it looked like routine interference, solar activity, cosmic rays, and perhaps another coronal mass ejection scattering data. But buried inside those gaps was something that did not behave like noise. When engineers at the MAVEN Mission Control Center examined ultraviolet readings from the planet's upper atmosphere, they noticed a repeating pulse, precise, rhythmic, measured in microseconds. It appeared only once every 93 minutes, matching the orbital period of something that did not belong to Mars. According to MAVEN's magnetometer, the pulse coincided with a transient change in the local magnetic field, an increase of 0.04 or a microtesla, lasting less than 2 seconds. To an untrained eye, it was nothing. To anyone familiar with electromagnetic diagnostics, it was impossible to ignore. Natural fluctuations wander, they do not march in lockstep. The readings aligned with another set of anomalies coming from ESA's trace gas orbiter. Infrared detectors on its ACS-MIR instrument had recorded thermal spikes in the 4.67 micrometer band, wavelengths associated not with atmospheric chemistry, but with active energy emission. When cross-referenced with planetary geometry, the source of the spike appeared to move, not with the Sun or Mars, but with an external object approaching from interplanetary space. That object had a name already, 3i Atlas. The third confirmed visitor from beyond our solar system. Its discovery announcement earlier that year barely made headlines. By the time the data began to whisper, most people had forgotten it existed. The numbers told another story. Orbital calculations from multiple observatories placed Atlas on a hyperbolic path with an eccentricity of 1.18 and an incoming velocity of 28 kilometers per second, nearly identical to Oumuamua and Borisov before it. Every interstellar object so far had entered the solar system on a trajectory that brushed within a few million kilometers of a planet carrying functioning transmitters. To most astronomers, that was a coincidence. To a handful of engineers staring at the gaps in their Mars data, it was geometry. On September 29th, the MAVEN team logged a full telemetry dropout lasting 43 minutes. During that window, every subsystem on the spacecraft continued running normally, yet no packets reached Earth. When contact resumed, timestamps had drifted by 2 minutes and 11 seconds. Too long for a clock error, too short for a safe mode event. The downlink buffer showed nothing but zeros, as if the instrument had recorded silence deliberately. Cross-agency email threads surfaced within hours. One engineer asked bluntly whether the blackout aligned with Atlas's predicted Mars flyby. It did, within, please, 6 minutes. Officially, NASA labelled the event a transient communication anomaly. Unofficially, every spectrometer in orbit over Mars went into diagnostic mode that night. A week later, an amateur analyst in Finland discovered that public telemetry archives had been re-uploaded with new checksums. The files were identical except for a single byte difference in the metadata, an indicator that the original dataset had been reopened, processed, and saved again. When questioned, the mission data officer replied that compression protocols were updated. No such update was logged anywhere else in NASA's repositories. The pattern was repeating, the same silence, the same adjustments, the same explanations that had followed Oumuamua in 2017 and Borisov in 2019. Each time the data came first, the retraction second, and the question was never officially answered. Was the universe still throwing rocks at us, or were we starting to intercept something else? On October 2nd, 2025, ESA's Mars Express recorded an unexpected ultraviolet emission at 190 nanometers from the planet's night side. a wavelength associated with carbon monoxide ions, but far stronger than any known auroral mechanism. For 20 seconds, Mars glowed faintly where it should have been dark. When MAVEN's instruments turned to face that region, they caught residual charged particles moving upward, not downward. Energy flows out of the atmosphere into space. Something had disturbed the planet from above. That is where the investigation began. What looked like noise became a pattern, and pattern became a question. Why did every instrument on Mars blink at the exact moment an interstellar visitor swept past? And why did the official channel stay silent for 43 days before releasing any data at all? Because the deeper the analysts dug, the clearer it became. This was not an isolated glitch. It was part of a timeline. The silence of Mars' orbit is deceptive. Every instrument whispers, not in words, but in photons, ions, and faint signatures that only reveal themselves after hours of decoding. In early October 2025, those whispers turned strange. ESA's TRACE, gas orbiter, armed with its twin instruments NOMAD and ACS, scanned the thin Martian atmosphere and found something that should not exist. Infrared spectra around 2.7 micrometers showed a sudden enhancement in water vapor absorption. Mars's seasons could not explain it. No dust storm, no polar release matched the timing. The anomaly appeared only when 3 Atlas passed behind Mars from the orbiter's line of sight. For 12 hours, the spectra bent, as if light from the sun had filtered through an invisible tail. If true, Mars had just performed the first extrasolar transit spectroscopy in human history. Residuals reached 4 sigma confidence before vanishing under a new heading in the database: atmospheric retrieval uncertainty. That phrase appears whenever data cannot be reconciled with current models. It is science's equivalent of "we're not ready to discuss this." The ACS MIR instrument, working in the mid-infrared range, registered dust temperatures near 260 Kelvin, 40 degrees above expectation for that distance from the Sun. No known natural mechanism could sustain such warmth without rapid cooling. Natural explanations existed: volatile ices, stochastic heating, but none persisted across multiple readings. When those files were finally posted publicly in March 2026, large sections were flagged provisional. That status prevents citation in journals. The data was visible but unusable, yet the numbers spoke. At 1.6 astronomical units from the Sun, 260 Kelvin means active energy input, chemical, mechanical, or something unknown. The coincidences piled up. Oumuamua's unexplained acceleration in 2017, Borisov's abnormal carbon monoxide output in 2019, and Atlas's excess heat in 2025. 3 objects, 3 anomalies, 3 eras. Then came the missing 43 minutes in ACS telemetry on October 3rd. No safe mode trigger, no orbital eclipse, just a clean hole in otherwise flawless data. The timestamp aligned within 10 minutes of Atlas's closest approach to Mars. Coincidence, perhaps. Coincidences multiply quickly in space science. Infrared anomalies could still mean dust, volatile jets, or even outgassing. But a hypothesis began to surface among the quiet channels: controlled venting, energy management rather than evaporation. The idea was dismissed publicly, but the question hung in classified email chains. If Atlas was active, was it observing, calibrating, or simply passing through? ESA repeated data under validation. NASA called the ultraviolet variations solar input. But cross-checking with ACE solar wind logs showed no such flux. The data refused to behave. And that's how a few independent analysts began their open review. Citizen, scientists downloading NOMAD datasets, checking 2.7 micron retrievals, and confirming the patterns for themselves. The mystery was no longer owned by institutions. It belonged to anyone who could read a CSV file. Because sometimes silence is the loudest form of admission. Between October 3rd and November 15th, the public Mars archives froze. No new telemetry, no updates, no camera uploads. The gap became known simply as the 43 days. Inside that silence, data moved elsewhere. Packet routing records later revealed that telemetry from the Mars Reconnaissance Orbiter, MAVEN, and TGO was duplicated to a private mirror network at NASA's Goddard Space Flight Center, a node reserved for cross-agency reviews. That mirror is used only during emergencies. None had been declared. On November 17th, NASA released a compressed update citing archive synchronization. Independent checksum comparisons proved the files were altered. Minor changes, metadata edits, but enough to reset their upload timestamps. Someone had reopened history. Freedom of Information Act requests returned polite denials, data under revalidation. Yet internal memos, later leaked, showed engineers discussing unexplainable phase coherence in magnetometer signals, oscillations at 4.6 Hz that repeated every 90 minutes. They called them heartbeat spikes. The name never appeared in public documentation. In Europe, the story was similar. ESA's Planetary Science Archive went read-only for 3 weeks. When it returned, certain infrared datasets bore a new watermark, derived from level 0 data, access restricted. To most people, that meant nothing. To data analysts, it meant the raw measurements had been replaced by processed approximations. 43 days after the anomaly began, normal operations resumed. No explanation, no summary report, just silence, and then routine. Except for one line in ESA's internal newsletter, Joint Mars Atmospheric Workshop scheduled to review 2025 telemetry anomalies. The workshop never published proceedings. Those 43 days became the hinge on which the rest of the story turned. Not proof of conspiracy, but proof of hesitation. Every time humanity encounters the unknown, it reaches for procedure. And procedure, by design, takes time. The first visible clue arrived not from orbit, but from the surface. On Sol 1612, Perseverance's Mastcam-Z captured an image sequence scheduled as part of its regular horizon survey near Jezero crater. The automated imaging software, operating in paired exposures, briefly switched to its secondary optical filter, a filter rarely used, designed to catch fine dust in motion. That frame should have shown the same dull Martian sky. Instead, the processed image revealed a thin, luminous streak arcing diagonally across the frame. The streak was straight, sharp-edged, and most importantly, color dispersed. A signature of a moving light source captured mid-frame. Perseverance's internal clock registered the exposure at 17:02:41 local time. When the image packet reached Earth, telemetry from Maven logged a simultaneous blip in magnetometer data, a sudden, narrow 0.04 microtesla spike lasting precisely 1 second. The same pattern seen in orbit, now mirrored on the ground. At first, NASA classified the photo under calibration artifacts. The designation meant a routine error caused by dust or cosmic rays. But within the mission team, debate began. Dust never produces color dispersion. Cosmic rays affect only a few pixels, not a whole diagonal line. And dispersion means one thing: light passes through optics while moving. Engineers attempted to trace the geometry. If the streak represented a moving object, its apparent speed across the frame implied a distance of a few hundred kilometers. Too slow for meteors, too high for drones, too controlled for debris. Cross-referencing with Mars Reconnaissance Orbiter images taken minutes later showed nothing. Whatever it was, it reflected and vanished within seconds. One mission analyst quietly ran a spectral decomposition on the pixels. 3 narrow peaks appeared: 532, 635, and 810 nanometers. Those corresponded exactly to green, red, and near-infrared laser wavelengths used in Earth-based optical communications. The coincidence was too clean. Someone, or something, had emitted a signal using our own technology's signature range. By policy, all imagery potentially showing unexplained light sources must be reviewed by the Planetary Protection Office before release. Weeks passed. When the Sol 1612 data finally went public, the frame count had been reduced. The streak image was gone. In its place was a compressed placeholder labelled Image Checksum Mismatch. Independent researchers discovered the missing file through cached thumbnails still hosted on the NASA Mirror server. The image was unmistakable. It had not been an artifact. Amateurs and professionals alike began analysing it. They compared Perseverance's camera calibration data, exposure timing, and azimuth with Maven's orbital parameters. If the trajectory was extrapolated backward, it traced a line to a region just outside Mars's exosphere, the exact vector of 3I Atlas's flyby 3 days earlier. The geometry was perfect within the margin of error. Perseverance's imaging schedule showed no anomaly at the time, yet the file numbering jumped. Image 1612, 38 missing, 1612.339, replaced by a duplicate of 16 to 12.37. The pattern hinted at manual intervention after downlink. Why remove one frame? Why replace another? Questions circulated quietly among analysts who had seen the raw feed. A second curiosity came later. During data calibration, the rover's environmental sensors showed a 0.6 Kelvin rise in local temperature coinciding with the exposure timestamp. That change could be minor, yet in Jezero's near vacuum, heat transfer that rapid usually implies radiant input. Something had momentarily illuminated the rover's surroundings from above. The connection to 3i, Atlas, grew stronger when the same timestamp appeared in logs from the InSight seismometer, a faint micro-tremor pattern repeating every 93 minutes for several hours after the event. Planet, orbit and surface all shared the same rhythm. When independent researchers correlated everything, image time, MAVEN field pulse, TGO spectral anomaly, the synchronization was impossible to dismiss. The chance of coincidence fell below 1 in 10 million. Natural phenomena could overlap, but not this precisely, not across multiple instruments built by different agencies thousands of kilometers apart. Officially, the Sol 16-12 frame remains unacknowledged. Unofficially, it became a legend, the photograph that might have captured the first measurable interaction between an interstellar object and a human machine. A streak of colour frozen in time, a visual echo of a conversation that may have begun before we even realised we were speaking. For those who worked on the mission, the moment changed everything. From that day, Mars was no longer just another planet we explored. It had become part of a larger geometry, a node in a communication lattice that spanned interstellar space. The official story remained simple. 3i Atlas was a natural fragment of ice and rock from another star. But behind the curtain, a debate unlike any in modern astronomy was already underway. The first meeting took place at the Jet Propulsion Laboratory on December 12, 2025. 15 scientists, 5 agency representatives, no recording devices. The minutes were marked restricted technical consultation. Those who attended still call it the night certainty fractured. Dr. Elena Serrano, a spectroscopist from ESA, opened with the data. She projected thermal curves showing the same 4.67 micrometer emission spike observed by TGO. She highlighted the symmetry. The emission rose and fell within exactly 1.2 hours, matching the orbital resonance of MAVEN's magnetic anomalies. She asked a single question: what process in nature repeats with machine precision? No one answered. Dr. Hiroshi Tanaka from JAXA suggested rotating jets, volatiles venting periodically as the object spun. He showed models using CO and CO2 sublimation. They worked until the energy balance collapsed. To sustain those emissions, Atlas would have required an internal heat source 10 times higher than solar absorption allowed. No natural albedo could explain it. Then came Dr. Maria Serrano's colleague from Goddard, Dr. Patrick Nguyen. He revealed something few outside DSN operations had seen: narrowband telemetry spikes embedded in the downlink noise floor at 8.415 GHz, exactly the frequency of the Deep Space Network's own Mars uplinks. Each spike lasted less than a second, appearing whenever the 43-minute telemetry dropouts occurred. To remove interference, engineers had turned off local transmitters during those periods, yet the spikes persisted. That meant the source was external. Nguyen's analysis showed that the spikes followed a binary phase pattern, alternating phase shifts every 2 seconds. When plotted, they formed a stepped sequence: 1, 4, 9, 15, 22, 32. A mathematician in the room recognized it immediately. The Golomb ruler sequence, the same one used in Earth's calibration signals for Project Echo tests. Someone whispered, "It's reflecting us." Another replied, "No, it's replying." Arguments erupted. Half the room called it feedback, Earth's own signal bouncing off an irregular surface. Others countered that a reflection would smear frequencies, not sharpen them. The coherence was too perfect. Dr. Serrano concluded quietly, "If it's feedback, it's intelligent feedback." No one laughed. By the end of the meeting, a draft memo circulated. Recommend classification of 3i Atlas as transient active object. Further public comment discouraged pending review. Within days, access to the raw telemetry server required new credentials. The press releases stayed routine. The debate went underground. 2 weeks later, an internal video conference linked JPL, ESA, and MIT Lincoln Laboratory. Agenda: anomalous narrowband, energy sources. The notes were later leaked, showing the discussion had turned to feasibility, how an interstellar probe might harvest energy while transiting a planetary system. Dr. Tanaka proposed magnetic induction from solar wind plasma, citing probe concepts tested in Japan's space tether experiment. At interstellar velocities, a conductive structure could indeed generate kilowatts. Others calculated mass estimates based on Atlas's light curve amplitude. If its albedo was near unity, the object's diameter could be under 40 meters. A metallic cylinder of that size would match both the brightness and the thermal behavior, but no telescope had resolved its shape. All they had were light curves and a single faint radar ping from Goldstone, showing an echo duration inconsistent with any natural fragment. That echo, 0.3 milliseconds long, implied a flat surface roughly 45 meters across. The radar cross-section was stable over 2 rotations. Debris tumbles chaotically. This one pirouetted with grace. The question of artificiality was no longer taboo, it was arithmetic. Each new measurement chipped away at the idea of randomness. Every simulation that tried to recreate the anomalies failed unless some variable, albedo, rotation, emission phase, was forced into unnatural precision. The debate split into camps. The physicists called it a coincidence, the engineers called it design, the administrators called for silence. In January 2026, a document labelled Echo Phase Continuity Protocol circulated internally. It authorised continued monitoring of the same frequency bands used in DSN calibration, with explicit instructions not to broadcast. Observation only. The rationale: if something was listening, humanity had already spoken once. Now it was time to listen back. Unofficially, the protocol became known as Project Echo. Officially, it didn't exist. For the scientists involved, the discovery carried a paradox. To announce it without proof would destroy credibility. To stay silent risked missing the greatest event in history. So they chose the middle path: measure, verify, wait. By the end of that winter, 3I Atlas had left the inner solar system, fading into the cold beyond Jupiter. The instruments returned to normal. The data pipeline resumed. But something fundamental had shifted. They were no longer looking for objects. They were listening for intent. When the next signal came, months later, it would no longer surprise them. It would challenge the very definition of silence. The story of Project Echo begins with an unsigned memo. It carried no letterhead, only a timestamp, February 19th, 2026, 3:14 UTC. The text was brief, 1 sentence and a checksum. If coherence persists beyond orbital horizon, initiate controlled carrier. No one knows who wrote it. But within 12 hours, the Deep Space Network logged a test signal from Goldstone's 70-meter dish, exactly at 8.415 GHz, the same frequency where the anomalous Mars spikes had first appeared. Officially, it was a calibration run. Unofficially, it became known among engineers as the night we answered back. The transmission lasted 3 minutes. Its power was modest, 20 kilowatts continuous, but the beam was coherent, phase-locked to a hydrogen maser. Instead of the usual telemetry packet, the payload was a simple mathematical preamble. Prime numbers from 2 to 101, followed by a binary representation of the hydrogen hyperfine line. Anyone, human or otherwise, would recognise it as artificial. At Goldstone, the engineers watched the downlink spectrum for reflections. At Canberra and Madrid, the other 2 DSN sites recorded parallel bands. For 43 minutes, silence. Then, at T+43 minutes exactly, a whisper of energy, so faint it sat 1 decibel above noise floor, appeared on the return channel. It matched the outgoing carrier's polarization and phase, offset by 180 degrees. To most, that would read as echo, Earth's own signal bouncing from Mars's ionosphere. But ionospheric reflections fade in seconds, not minutes, and never mirror phase so perfectly. Someone in the control room said quietly, "It came back coherent." They recorded everything, filed the logs under experimental telemetry run A11 and moved on. No press release, no statement. The data sat dormant for months, encrypted on an internal server called Calypso. Only later did analysts realise what they had captured. When they re-examined the waveform at high resolution, the delay pattern of the returning signal wasn't constant. it drifted in discrete steps, 2 microseconds forward, then 1 back, forming a modulation identical to the Golomb ruler sequence that had haunted the Mars anomalies. The signal was mimicking the language Earth itself had used in its calibration pulses. Project Echo was never supposed to be active. It began as a thought experiment. If a non-terrestrial intelligence were monitoring us, could a structured signal provoke a measurable reaction? The risk was political as much as scientific. No agency wanted headlines claiming first contact, so the tests ran under maintenance codes, hidden in the telemetry noise. By March 2026, 6 more calibrations followed. Each was sent during periods when 3+ Atlas's extrapolated trajectory intersected Earth's orbital plane. Each returned with the same pattern, delayed coherence. When the last one ended, the correlation curve formed a clean diagonal line, response lag increasing exactly as the object's air distance grew. A straight line on a log plot is physics, a stepped one is intent. The debate reignited. Was space itself feeding back resonance? Could the DSN's multiple dishes be cross-talking through interplanetary plasma? Engineers modelled it. No combination of equipment or ionospheric conditions could reproduce the precise timing offsets. Whatever produced the return was external and adaptive. Within weeks, access to the Calypso archive required 2-factor authentication and physical key verification. Researchers who requested the files received the same reply: dataset reclassified under interagency review. In bureaucratic language, that meant buried. But silence doesn't last forever. A year later, in a technical paper on radio wave propagation, a footnote appeared acknowledging unexpected phase-coherent echoes recorded during 2026 calibration exercises. It listed no authors, no references, only a DOI. The paper was indexed for 3 days before being withdrawn. By then, hundreds had downloaded it. That single document confirmed what rumours had claimed. Project Echo had been real, and it had produced measurable results. It proved that a signal left Earth, travelled billions of kilometres, and returned with a structure not present in the transmission. Physics had no easy explanation. Official channels called it an instrumentation anomaly. Unofficial circles called it humanity's first handshake across the void. Whatever the truth, one fact remained. After Project Echo, every deep space network test included an additional field in its metadata: return phase monitoring. Enabled. Even if no one admitted it, they were still listening. And somewhere beyond Mars's orbit, 3i Atlas kept moving, faint, silent, yet never truly gone. The universe had heard our voice, and for a moment, it had spoken back. The discovery that a return signal existed changed the meaning of silence itself. Every quiet channel was now suspect, every unmodulated carrier a potential reply waiting to be recognized. The next phase of the investigation turned from transmission to interpretation. How do you tell the difference between random reflection and deliberate resonance? By mid-2026, an internal working group had formed quietly, under the coordination of NASA's Space Communications and Navigation Program. Its members were drawn from DSN, ESA's EastRack network, JAXA's Yasuda station, and a handful of civilian observatories with access to coherent receivers. They met under a new classification heading, Crossband Resonance Study. The name gave away nothing, which was the point. The group's first task was to reproduce the phenomenon under controlled conditions. They directed the Canberra 70-metre antenna to emit a sequence of binary phase shift keying pulses, each consisting of 1,024 bits repeated every 4 seconds. Every site listening in the X-band and K-band recorded the results. Out of 128 sessions, 127 returned noise, exactly as theory predicted. Only one showed a phase-locked echo, again 43 minutes after transmission, again from the direction of the outer planets. The numbers made the hairs on the back of every engineer's neck stand up. The measured delay matched the expected round-trip light time for an object near 9 astronomical units from the Sun, roughly the orbit of Saturn. But there was no known spacecraft there capable of retransmitting coherent signals. The last probe in that region, Cassini, had been deorbited into Saturn 9 years earlier. When they folded the signal, they saw something new. The phase reversals that should have been random were not. The offset between consecutive bits followed a harmonic ratio, 3, 2, 5, 3, 2, 5. 6 pulses repeating endlessly. A mathematical rhythm, too simple to carry data, too deliberate to be chance. One analyst described it as a heartbeat coded in geometry. They cross-checked everything. Solar flares? None. DSN crosstalk ruled out. Reflections from Jupiter's magnetosphere? Mathematically impossible. Only one variable fit the equation, a coherent transponder moving along 3I Atlas's predicted trajectory. By late July, the pattern stabilized. The return amplitude decayed exactly as 1 divided by the square of the distance, consistent with a point source emitting equal power in all directions. That meant whatever was out there was not beaming directly at Earth, but radiating broadly. It was broadcasting, not targeting. This finding forced a change in vocabulary. What had been called echo now became transmission. The term mirror appeared in the internal documentation. The mirror wasn't a poetic metaphor anymore. It was the label for an active emitter of coherent energy somewhere beyond Jupiter. The next challenge was decoding. Every attempt to demodulate the 3, 2, 5 rhythm-yielded patterns that looked statistical at first, then suspiciously structured. Autocorrelation plots revealed peaks separated by prime intervals. In other words, the signal was self-referential. It described its own timing in the language of prime numbers. That is the simplest possible definition of mathematics across cultures. In September, analysts converted the phase steps into binary differentials. The resulting stream, when plotted as black and white pixels, formed a grid, 127 by 127, a prime dimension, the same pattern used in humanity's Project Echo messages. Across the center ran a diagonal gradient of increasing frequency. To some, it looked like noise. To others, it looked like acknowledgement. No public statement was made. The mirror transmission, as it became known, was circulated among only 30 people worldwide. But data leaks have a way of moving faster than official channels. Within weeks, encrypted files labelled DSN Return Channel Phase Analysis appeared on academic file-sharing networks. Thousands of physicists downloaded them before deletion orders took effect. Those who analysed the files independently reached a startling conclusion. When the phase information was reconstructed in 3 dimensions, time, frequency, amplitude, it resembled a coherent interference pattern. In physical terms, that is a hologram. If projected into space, the pattern would generate a faint repeating wavefront shaped like a logarithmic spiral. It was as if the returning signal wasn't trying to send a message but to show a principle. Interference, resonance, geometry. The basic grammar of physics. Inside the DSN Coordination Center, an engineer finally put it into words. If someone wanted to prove they understood wave mechanics but nothing about our language, this is exactly what they'd send. By the end of 2026, the mirror transmission had repeated 9 times, each occurrence weaker than the last, each drifting further out. Telemetry predicted the source would exit the heliopause by mid-2027. After that, even the most powerful receivers on Earth would hear nothing. Before the final transmission faded, the working group drafted a report for the United Nations Office for Outer Space Affairs. The conclusion was cautious. Observed coherence consistent with unknown external emitter. Probability of anthropogenic origin below 1%. They submitted it through official channels. It was received, acknowledged, and then classified. No one outside the network ever saw the complete report. But every participating scientist left the project changed. They had learned that the universe can answer in silence, that communication might not mean words at all, and that once you cross the threshold where signal becomes possible, you never return to true quiet again. Somewhere beyond Saturn, the mirror drifted into darkness, its last whisper absorbed by cosmic noise. The instruments went back to routine, calibration, and for the first time in a year, the plots on the monitors looked normal. Yet for those who had witnessed the anomaly, normal would never mean the same thing again. By early 2027, silence had become a problem of logistics. If an interstellar object could trigger coherent echoes once, then it might again. But to detect it, humanity needed to look differently, everywhere, all at once. That realization gave birth to what insiders called the search grid. It began as a technical directive, circulated quietly through the International Astronomical Union and several national observatories, synchronize all sky survey archives, cross-correlate motion vectors in real time, and flag any object entering the inner solar system with eccentricity greater than 1. In plain language, watch for visitors. The system wasn't new, but the integration was unprecedented. Observatories in Hawaii, Chile, South Africa, and the Canary Islands began operating as a single synthetic aperture telescope, a virtual instrument covering the entire night sky in overlapping exposures. Each station uploaded astrometric data to a shared cloud that ran machine learning models trained to recognize non-gravitational acceleration, spectral anomalies, and thermal irregularities. The network's spine was the Pan-STARRS array in Maui, connected directly to the European Gaia Data Processing Center. Every 72 hours, the algorithms remapped moving points of light against gravitational expectations. Any deviation triggered a global alert across the network. Telescopes, radar arrays, and even deep space antennas were automatically tasked to observe. The goal was not just detection, it was correlation. If Mars ever blinked again, every eye in the solar system would notice simultaneously. Inside NASA, the initiative went by a more poetic name, Project Sentinel. It wasn't officially linked to Project Echo, but everyone understood the lineage. Where Echo had been an experiment in transmission, Sentinel was its listening half. If something was out there, Sentinel would hear it first. Funding appeared overnight. The National Science Foundation quietly redirected portions of its exoplanet budget. The European Commission folded new detection algorithms into its Space Situational Awareness program. Even the private sector joined in. SpaceX offered access to Starlink's phased array network for passive radio listening, turning thousands of orbiting satellites into a low-frequency interferometer stretching around the globe. For the first time in history, humanity built a sensory organ capable of hearing the solar system breathe. By March 2027, Sentinel logged its first dry run. The training exercise simulated the inbound trajectory of a hypothetical interstellar body moving at 30 kilometers per second, entering from the direction of Lyra. The system detected it within hours, triangulated its orbit, and cross-tagged it with the DSN to listen for coherent returns. Everything worked flawlessly. The test proved one thing: the infrastructure to catch another Atlas already existed, but tests are one thing, reality is another. That same month, astronomers noticed a faint moving point in the data stream from the Vera Rubin Observatory. Its velocity vector matched the profile almost perfectly. Incoming from Lyra, eccentricity 1.12, estimated size 200 meters. It was labeled Candidate 4I. No one wanted to say it out loud, but the timing was uncanny. Barely 3 years after Atlas, the next visitor was on approach. Publicly, Discovery announcements used the same cautious language: hyperbolic trajectory, likely natural origin. Privately, Sentinel operators updated their monitoring schedules to round the clock. They activated the new heliospheric listening mode, a setting that tied together every radio observatory from Goldstone to FAST, all locked on one narrow frequency band, 8.4 15 GHz. For weeks, nothing unusual appeared. Then, at 3:18 UTC on May 17th, the system logged a transient burst, 6.4 seconds long narrowband, coherent within 1 Hz, the same frequency, the same modulation, the same rhythm. The first person to see it was a graduate student working the night shift in Green Bank, West Virginia. He thought it was interference until the spectrum analyzer froze, displaying a thin vertical line where there should have been a blur. He called his supervisor. Minutes later, the file was mirrored across 3 continents. The search grid had worked, but success brought new tension. The object's predicted orbit placed its perihelion within 0.7 astronomical units, closer to the Sun than Venus. Any follow-up observation would require coordination between space-based and ground-based assets. And for the first time, the question of communication resurfaced. If another interstellar body could echo back our signal, should we transmit again? Or had the first reply already said enough? The scientists debated through encrypted channels. Some argued for restraint: observe, record, stay silent. Others claimed that data without interaction was meaningless. The universe had already proven it could whisper. Maybe now it was time to speak clearly. In Geneva, the Interstellar Response Committee convened a confidential meeting. Minutes later, a short document circulated under restricted access. Guidelines for Intentional Signal Transmission During Interstellar Object Observation. Its first line read, "Any active emission must be approved by unanimous international consensus." In practice, that meant no one could act. But the universe doesn't wait for policy. Candidate 4I was coming fast, and the search grid could only listen. Every dish, every receiver, every algorithm pointed outward, waiting for a pattern, a pulse, a sign. And when it came, it would not arrive quietly. The search grid had transformed humanity into a single nervous system. Every telescope was now a neuron, every data stream a synapse. For the first time, the species could act as one listening organism, and somewhere between the stars something was about to test whether that organism was ready. For weeks, the search grid recorded nothing but routine cosmic chatter. Then, on the night of May 29, 2025, the data changed. At exactly hours 2:47 UTC, the Greenbank telescope detected a returning carrier at 8.415 GHz, the same frequency that had defined Project Echo. The signal rose out of the noise like a blade, held steady for 6 seconds, and vanished. Its bandwidth was only 1 Hz, its phase coherent to 10 decimal places. That level of stability is beyond what natural processes can maintain. Even the most regular pulses fluctuate by several parts per billion. When cross-checked with data from the Meerkat Array in South Africa and the FAST telescope in China, the timing aligned perfectly. All 3 dishes had received the same pulse within the same microsecond. Triangulation placed the source somewhere in the outer solar system, roughly in the direction of the constellation Aquila. That was the predicted entry path of Candidate 4I. For the next 3 nights, the search grid locked onto that region, gathering continuous spectral data. The pattern repeated every 24 hours, 6 seconds of perfect coherence followed by silence. Each pulse carried a faint secondary harmonic at 4.67 micrometers, identical to the thermal emission first observed near Mars during Atlas's flyby 2 years earlier. The probability of coincidence fell below 1 in a billion. By June 3rd, every deep space antenna on Earth was aimed at Aquila. Even the retired Arecibo feed, still partially operational as a passive receiver, was temporarily reactivated to contribute. The network functioned as one vast interferometer, capable of resolving details finer than a kilometre at interstellar distances. When the first full-resolution spectrograms were processed, the analysts froze. The returning signal was not just a single frequency. It was a cluster of harmonics separated by prime number intervals: 2, 3, 5, 7, 11, 13. That pattern does not occur in nature. It was as if the source were reciting the fundamental structure of mathematics itself. The phenomenon was dubbed the mirror return. Official reports called it the second coherence event. It lasted 43 days, the same duration as the Mars data silence 2 years before. Every day at nearly the same hour, the signal repeated, decaying slightly as the object moved away from the Sun. Each transmission was identical except for a single feature. The phase offset rotated by a fraction corresponding to the Earth's orbital motion. That meant the source was compensating for our movement. It was tracking us. The response inside scientific institutions was immediate and divided. One camp argued the signals were self-generated artifacts, a feedback loop within the network's own synchronization algorithms. Another camp pointed out that disabling those algorithms didn't stop the pulses. The transmissions continued even when the entire search grid switched to passive listening mode. When the pattern was converted to binary differentials, the bit stream formed a structure similar to the one that had emerged from Project Echo, a 127 by 127 grid. But this time, the grid was not blank. The amplitude of each bit formed a faint gradient, what looked like the outline of an orbit. In the center, a small bright curve intersected a line drawn from the Sun to the third planet. The coordinates matched Earth's position at the exact moment of transmission. Some called it a coincidence, others called it recognition. Behind closed doors, the Interstellar Response Committee met continuously. Minutes from those meetings, later leaked, show the scale of their confusion. Every simulation designed to reproduce the event failed. No known astrophysical mechanism could emit such a clean phase coherent signal across multiple frequencies with prime number spacing. The only comparable systems were human-made atomic clocks. When pressed by the media, NASA released a carefully worded statement. An anomalous narrowband signal of probable terrestrial reflection origin is under review. It was the same language used for Oumuamua, Borisov and Atlas. The phrase probable reflection became a shield for uncertainty, but reflection didn't explain the correlation between signal phase and Earth's orbit. It didn't explain the prime number harmonics, and it certainly didn't explain the identical 43-day duration. On social media, speculation exploded. Amateurs plotted waveforms and overlaid them on planetary positions, claiming to see encoded maps. Skeptics dismissed the data as confirmation bias. The debate spilled beyond science into philosophy, theology, and even art. For a brief moment, the world seemed to be united by a single question. Are we still alone? Inside observatories, the atmosphere was quieter but more electric. Teams began running independent verifications. At the Very Large Array in New Mexico, engineers confirmed that the carrier persisted even when pointed several degrees away from the source. That suggested the signal wasn't directional but pervasive, possibly diffused through plasma or some larger medium. At Lincoln Laboratory, a group of cryptographers analysed the timing of the harmonics. They found that when plotted over time, the sequence of peaks matched the binary representation of a mathematical constant, 3.22926. Pi, the universal ratio between circumference and diameter, the same number was encoded in Project Echo's first message a year earlier. That was the moment speculation hardened into conviction. If chance could produce one coincidence, it could not produce them all. Someone, or something, was using our own symbols to mirror us. As the 43rd day approached, the amplitude of the pulses declined sharply. The last transmission arrived on July 11th. Its spectrum was identical to the first, except for one detail. At the end of the pulse, for just 1/10 of a second, a secondary tone appeared, offset by exactly the hydrogen hyperfine frequency, 1420.475 MHz, scaled into the X-band by a factor of 5.927. That scaling ratio had no precedent in known signals, but when applied inversely, it translated back to the speed of light, within measurement error. It was as if the signal had signed its name using the fundamental constants of the universe. After that, silence returned. The search grid kept listening for weeks. Nothing more came. No new bursts, no harmonics, no echoes. The pattern ended as precisely as it began. Scientists called it closure. Philosophers called it restraint. But among those who had followed the data since Mars, one thought persisted. Perhaps the silence itself was part of the message. If the mirror had spoken once and then again, maybe the third step belonged to us. Before anyone could decide what to say, they had to answer a harder question: how to say it. The second coherence event had proved that the universe might be listening. Now, for the first time, humanity faced the challenge of constructing a message not for ourselves, but for whatever intelligence might be capable of hearing across light years. Project Echo had shown that a coherent carrier could travel billions of kilometers and return unchanged. That meant structure mattered more than strength. The task now was to design a structure that could outlast interpretation, communication at the level of physics, not culture. A new working group was formed under the Interstellar Response Committee. It brought together engineers from NASA's Jet Propulsion Laboratory, mathematicians from the SETI Institute, and information theorists from MIT's Lincoln Laboratory. They called themselves the Message Architecture Team. Their objective was deceptively simple: define the minimal expression of intelligence that could survive the vacuum of space. The first decision concerned the carrier itself. After weeks of modelling, the team settled on a narrowband coherent transmission at 8.415 GHz, the same frequency used in the mirror event. The logic was straightforward. If the phenomenon had chosen that frequency, it was already listening there. Power levels were conservative, 20 kilowatts continuous, beamed through a 70-metre DSN antenna, producing an effective radiated power of roughly 300 megawatts. Strong enough to be heard at the edge of the solar system, but not so strong as to resemble aggression. The next question was modulation. Natural processes scatter frequencies, intelligent systems organize them. To announce intention, the signal would use binary phase shift keying, flipping the carrier's phase by 180 degrees to encode ones and zeros. At 1 kilobit per second, a 3-minute transmission could contain 180,000 bits, enough for a mathematical greeting, a planetary map, and the blueprint of the system that built the message. But mathematics alone was not communication. Meaning required context. So the architects designed a header that defined universal constants, anchors any physicist could recognize. The opening sequence represented the hydrogen hyperfine transition frequency, not as a number, but as a unit of time, 7.04 times 10 to the negative 7 seconds. The following bits expressed the speed of light, setting a ratio between time and distance. Next came the value of pi, encoded in base 2 to establish numeric syntax. With those 3 constants, any recipient could reconstruct scale and language. After the header came geometry, a series of bitmaps arranged in prime dimensions, 127 by 127 pixels, to make clear the data was intentional. Each frame illustrated a fundamental concept: counting, addition, atomic structure, and planetary arrangement, then a logarithmic map of our solar system, showing planetary orbits as nested circles with Earth marked simply as reference 0. To conserve bandwidth, the images were compressed using Golomb-Rice coding, a simple pattern recognizable to any algorithm that understands repetition and variance. For error correction, they embedded Reed-Solomon parity blocks, the same method that still keeps Voyager's telemetry readable after decades in deep space. Every redundancy bit was insurance against entropy. The transmission clock derived from a hydrogen meso, accurate to 1 part in 10 to the 14th. That meant the frequency would drift less than a single hertz over the full sequence, an unmistakable signature of design. Finally came the payload, a description of the process rather than language. Instead of pictures of people or cultural symbols, the message encoded algorithms, feedback loops, orbital equations, and the logic of self-correction. It was humanity's essence translated into physics, a civilization defined not by what it built, but by how it learned. A secondary optical channel was added for redundancy, using a 50 nanometer laser from the Deep Space Optical Communication System. Each bit corresponded to a microsecond pulse, a rhythm distinct from any natural pulsar. At Mars range, the optical beam would spread to 70,000 kilometers, bright enough to register on any receiver capable of detecting coherence. The entire message required less energy than a household appliance uses in 1 second, yet carried the potential to alter human history. To avoid confusion, the entire sequence was time-stamped in barocentric dynamical time, the solar system's central reference frame, so any observer could reconstruct the moment of transmission with microsecond precision. After months of simulations, they performed a full-scale rehearsal. Goldstone transmitted to the Mars Reconnaissance Orbiter, which received the packet flawlessly, confirming that the encoding survived the void intact. The architecture was ready. Only one question remained: should they actually transmit? Some argued that readiness itself was enough, that the existence of the plan proved humanity's maturity. Others insisted that silence after confirmation was a form of dishonesty, that discovery demanded reply. In the final revision, the team added a closing checksum that served both as a verification field and as philosophy. When decoded into text, it read simply, "This signal is finite. 3 words, 64 bits, defining both the message and the species that created it, curious enough to reach out, cautious enough to acknowledge limits." The finished document was titled Interstellar Message Protocol, version 1.0. No agency ever authorized its use. It remains archived under checksum AE29 F3B1, waiting. Because in the language of exploration, readiness is already a kind of message. Detection was never supposed to make headlines. It was meant to live quietly in graphs and data archives, something scientists debated in conference rooms while the world slept. But when the signal from candidate 4I arrived, quiet didn't last even a day. It started as a 6-second transient caught by the breakthrough listen backend at Greenbank. A narrowband tone at 8.415 GHz, stable to within 1 Hz, lasting just long enough to be unmistakably deliberate. At first, it was logged as interference. Then the system flagged it again, phase coherent, repeating every 24 hours, matching the window of the mirror return. The automated classifier assigned it the highest possible confidence score, non-random structured source. Within minutes, the data replicated to SETI's cloud cluster in Berkeley. Cross-correlation confirmed it wasn't an instrument artifact. It was real, and it was coming from Aquila, the exact sector of the sky where 4I was predicted to pass. By 3 a.m, 16 scientists had received an internal email marked Level 2 event. 2 hours later, someone forwarded it to a journalist friend. By sunrise, cropped screenshots were trending on social media under the hashtag #ThirstFirstContact. In less than a day, the quiet work of verification became a global spectacle. NASA released a single sentence: "An anomalous narrowband signal is under review." The European Space Agency said nothing. The Chinese Academy of Sciences issued a denial that they were involved, but silence only amplified speculation. The more the agencies withheld, the more the public filled in the blanks. Forums dissected the waveform, overlaying it with pi ratios, Fibonacci spirals, and even Morse code. Television panels debated theology. Markets surged on aerospace stocks. In the absence of facts, narrative became currency. Inside observatories, the mood was different. 3 independent facilities, Meerkat in South Africa, FAST in China, and Effelsberg in Germany, detected the same carrier, same Doppler drift, all consistent with an object moving at 29 kilometers per second relative to the Sun. That correlation erased the last refuge of doubt. The signal wasn't local interference, it was astrophysical. The protocol dictated confidentiality for 72 hours to allow verification, but social media doesn't recognize protocols. By hour 12, speculation had reached every corner of the planet. By hour 24, the event dominated global news. By hour 36, religious leaders were making statements. The world had entered its first contact crisis, and no one was prepared for it. Governments scrambled. The United Nations convened emergency sessions behind closed doors. In Washington, Geneva, and Beijing, diplomats searched for language that didn't yet exist. Who speaks for Earth? Who decides what silence means? Meanwhile, the data kept coming. Each new detection aligned precisely with the object's predicted position, the same 6-second pulse repeating at perfect intervals. Then came the discovery that changed everything. The pulse pattern wasn't identical to Project Echo's original signal. The intervals were offset by 1 unit, an intentional shift, as though the sender were repeating our own pattern, but incremented by a constant. In digital terms, it was the smallest possible acknowledgement, received. The implications were staggering. If the return was simply a reflection, physics alone couldn't explain that shift. If it was a response, someone had not only heard us but understood the structure of our message enough to alter it deliberately. Verification turned into paralysis. The scientists wanted more data, governments wanted control, no one wanted responsibility. Inside the deep space network, engineers noticed something else, a faint secondary tone embedded within the primary carrier. When demodulated, it corresponded to a time delay that matched the round-trip light time from Earth to Mars and back. That meant the transmission path wasn't interstellar, it was bouncing off something within the solar system. The mirror was closer than anyone realized. Attempts to pinpoint its position failed. Each observatory produced slightly different triangulations, as though the source were not a point but a volume. Some proposed plasma reflection, others whispered about distributed technology. Every explanation collapsed under the weight of coherence. As the 72-hour confidentiality window expired, the world's major science agencies faced a decision: announce confirmation and risk chaos, or deny and risk being exposed by leaks. They chose the middle ground, a phrase polished by committees and lawyers. The signal is of unknown origin and remains under analysis. It satisfied no one. Conspiracy theorists claimed suppression. Academics demanded transparency. Politicians called for hearings. For the first time, data became a geopolitical weapon. The final press conference took place simultaneously in Washington, Paris, and Tokyo. Standing behind identical podiums, agency directors repeated the same script. The current evidence does not support an extraterrestrial origin. But when journalists asked whether the signal was artificial, none of them answered directly. The evasion spoke louder than confirmation ever could. After that, the transmission stopped. No new pulses, no harmonics, no coherence. Just silence. Again, perfect and complete. The contact crisis burned itself out in a few weeks. News cycles moved on, markets stabilised. But for those who had seen the raw data, nothing returned to normal. They knew the odds of coincidence were gone. They had witnessed communication in its simplest form, a mirror responding to a call. And yet the final paradox remained. If the mirror could hear us, why did it fall silent now? Was the experiment complete, or had it simply moved beyond our range? The scientists could not agree, governments would not say, and the public, once feverish with expectation, settled back into the rhythm of uncertainty. But somewhere in the archives, the waveform endures, 7 pulses, 6 seconds, 1 heartbeat between 2 civilizations still learning how to listen.